In this video, we are going to go over a logarithm function, logarithm differentiation, and there are two basic method or steps involved. One is taking log of both sides, and two is differentiating the resulting function. So let's solve. Let's say we are given y equal to what? X raised to the power of what? X. So in this question now, we're going to what? Say take log of both sides. So if you take log of both sides, we're going to have log y equal to log x to the power of what? X. This is what it means. So now we are going to now, under logarithm, you know that when we have, if you're having x to the power of x, we can what? We can drop this x to the front. We can move it to the front. So log y is equal to what? X log x. It's still the same thing. We only move the power to really drop the power under. Is it power? I'm not sure though. So now we can now differentiate each term. Remember I said whenever you're given ln y or log x, is what is 1 all over that number you're given, that log of what you're given, 1 all over what. By the time you differentiate a log, it's going to be 1 all over what? Y. So 1 all over y, the y over the x equal to, this is a product rule where we are going to keep s constant, multiply, then we'll differentiate the second one, which is 1 all over x, plus we keep so constant, then differentiate the first one. Differentiation of x is what? 1. This x will cancel what? This x. Then we're left with what? 1 all over y, the y over the s equal to 1 multiplied by log x multiplied by 1 is still log of x. So now we're going to make the y subject the formula by what? By multiplying both sides by y. So by 12 multiply both sides by y, we have 1 all over y, the y over the x equal to multiply by y, then 1 or y open bracket 1 plus log x close bracket, then this x will cancel, and this y will cancel this y, then we're left with what? The y over what? The x to be equal to y open bracket 1 plus what? Log x. This is the final answer. If you like, you can see you can replace this y, because from the beginning of the function we're giving y to be equal to this. In case where you're given this kind of function and they said you should prove that y equal to x raised to the power of x to be equal to what? This, which is the y over the s equal to x is the power of x open bracket 1 plus log x. This is how you can solve, because you might see equation, or you might be given equation where they will ask you to what? Prove that y equal to x to the power of x is equal to what? This function here. This is how you can solve using what? Logarithm differentiation. So let's move to equation 2. Equation 2, where we are giving y to be equal to tan x raised to power of sec x. We're still going to take log of both sides. By the time we take log of both sides, we're going to have log y equals to what? Log of all this, log of what? Tan x raised to the power of what? Sec x. Then now, like I said, you can drop what? You can drop this power under one of the laws of log. Then it's going to be sec x log tan x. So now we can differentiate. We cannot differentiate. So we don't differentiate log y. We're going to have 1 all over y multiplied by the y over what? The x equal to, this is a product rule. So we're going to keep the first one constant, sec x constant. Then we'll differentiate the second one, which is log of what? Tan x. And I said log is going to be 1 all over this thing. What's attached to log is tan x multiplied by what? Derivation. This is a function of a function multiplied by derivation of what's in the bracket. So which is tan. By the time we differentiate tan 2, we're going to have sec square x plus, we keep log tan x constant. Then we differentiate the first one. By the time we differentiate the first one, which is sec x, we're going to have what? Tan x sec x, tan x sec x. It's a constant derivation. Okay, so now let's write 1 over y, the y over the x equal to sec x multiplied by 1 multiplied by sec square x is going to be sec cube x all over tan x plus log tan x tan multiplied by tan x sec x. Okay, so now I'm going to what? Make the y the x of the formula by multiplying all through by what? All through by y. All through by what? So this y will cancel. So we're left with what? The y over what? The x to be equal to y open bracket sec square, sorry, sec cube x, sec cube, sec of cube, then x, not sec cube x, sec is power of 3x all over tan x plus log of tan x sec x. Remember, our y is equals to what? Tan x is power of sec x. So we can replace it. The y over the x equal to what? Tan x is the power of sec x open bracket sec is power of 3x all over tan x plus log tan x close bracket tan x sec x. So that's the final answer. This kind of question, they can still ask you to show that y equal to tan x is power of sec x is equal to what? All this function here. This is how we can also go over it. So it can also prove that y equal to tan x is power of sec x is equal to tan square x open bracket sec raised to the power of 3x all over tan x plus log tan x square x. So, okay, let's solve the last one. Y equal to x is to the power of cos 4x. So we're taking log of both sides. Log y equal to log x cos 4x. Remember I said we're going to drop the power, which is cos 4x log x. So we're going to differentiate now. We're going to differentiate now. So by the time we differentiate, we're going to have 1 over y multiplied by dy over the x equal to, we keep this constant, cos 4x constant, then differentiate this 1 over x, plus you keep 1 over y log x constant, then you differentiate this, which is going to be negative sine of x 4x multiplied by what, the angle, because this is what, a function of a function. Then we can rearrange 1 all over y, the y all over the x is equal to cos 4x multiplied by 1 is cos 4x all over x. Then since log x is multiplying minus sine 4x, we're going to have minus this was multiplying this was multiplying minus sine 4x, and minus 4 sine 4x multiplying log x. So we're going to have minus 4 sine 4x minus 4. The log is supposed to come before this, but let me just write it down. I'm going to rearrange it. Log x. So 1 all over y, the y over the x is equal to cos 4x all over x minus 4 log x sine 4x. Then we're going to multiply all through by y, so we can be able to eliminate this y. So I left with the y over the x equal to y open bracket cos 4x all over x minus 4 log x sine 4x, close the bracket. You can replace this x with this. The y over the x is equal to where's our y? It's our x is equal of cos 4x open bracket cos 4x all over x minus 4 log x sine 4x, close bracket. This is the final answer. They can also ask you to also prove that y equal to x is power of cos 4x is equal to what? All this here. Thanks for watching.